Okay, hi everyone. I missed all of you, and as you know, today class is online session. The reason for that, I was not sure how many of you interested in the in-person or online sessions. Even for online sessions, some of you might be around the world. Maybe this time is not suitable for you. So you can take this course in the asynchronous, which means like you can watch the videos and do the assignment at a different time, or synchronous means you are basically in your home, maybe around the world or even in the US, whenever that you are located. So again, as I explained to many of you, the class is a hybrid, which means you can be in person or online. If you even choose the in-person session, if you have some worries about your healthcare, even from the middle of semester, you can change to synchronous or asynchronous. So we have a wide variety of options. My personal preference was in-person classes. The reason I made the class hybrid, but no worries if you choose either options or even you change your preference. Hopefully all of you will be very healthy and we get rid of this weird situation soon. Okay, thank you. So some of you are commenting me that you can make it public or private, anything that you prefer. So if you are, today we have a synchronous online session. It means we can have like talk with each other. You can even use your own computer microphone or video, or you can just type your comments. Either way, it's totally fine. Even from next class, that our class would be hybrid. Even if you are taking as a synchronous format, you can still collaborate with me even or with your other friends. For the asynchronous version, same as previous semesters, if you had classes with me, we have a GroupMe chat. In the GroupMe chat, you can also communicate with me or with all of your friends. The good thing about that, many of you might have a similar questions, or again, some you are in a synchronous format. So with that, you can still communicate with your friends that are in the United States or another part of the world. Another good thing, as you know, I have so many extra credits, and one of them is coming from your class attendance or participation. Some of them comes from how you help your friend or GroupMe, because I assume most of the questions are same. So you can help them get some extra credits, or I post some extra credit problems. And also from that, you also can get some extra credit that helps. But again, at the end of semester, I need to be fair for everyone. So if I change any grade, it depends on what you did during the semester. I would love like give all of you A. I will be more than happy, but it should be in the fair situation. I cannot like somebody maybe work a lot. I mean, collaborate with all of the friends, did everything right and got A. And it's not fair to just give another person that were not that much collaborative and didn't spend that much of time. So again, my point of view, I love everybody gets A, and at the end, all of you get a good job or go to a PhD program if you're interested. Having said about job and PhD programs, I'll just give you some good insights. My brother just got a data scientist position at Apple, and he graduated from a top 5 university in the world. But the point that even for my brother, he first of all he started from a very small company in somewhere, I think Concord, Massachusetts. Then after that, he went to a middle-sized company. I think if some you have some civil engineer mechanical background, he worked in the ANSYS, which is a mid-sized company, and then he got a position in Apple. So, I mean, maybe very small portion of people just go to a very big company right away, but for more than 90% of people, they start from small companies, then mid-size, and there's some steps. I mean, they might have some connections and maybe they get good position, but for vast majority of people, there's some steps. So first step, you need to learn very well. You need to spend time during your education, learn good techniques. Usually the next step is studying from a company, a mid-size, or even a small company, same as my brother. He worked in like I think in companies less than 20 people in his first job, and I mean, people just look at your performance. I mean, graduating from a prestigious program is good, and actually your university has a really good ranking. You're in a good ranking university, but there's some steps that you need to follow. I mean, hopefully everybody has a connection instead from a very large institution or company. If you're in the PhD program, if you want to get a PhD degree, let me tell you something. You know, in the undergraduate studies, people teach you everything. They basically bring everything to you and let you to learn and explain everything to you. When you go to master degree, usually it's like some of your learning comes from your own personal work, and some of them from your professor. There is some reason people are not lazy to teach you everything, especially like they can make more money by teaching. Why not? I mean, they can teach more courses, but this modern world, there's so many new topics and content coming up every day, and people don't have time to just like teach everything to everyone. So basically one portion of your learning is by yourself, which I mean and in my courses, some of those learning, I give some extra credits for those things. Because something are certainly under scope of your course that I teach you, and I know, I mean, you just, actually your second year, you should start learning by yourself too, but I mean, the part that are kind of out of the scope of the class, I usually give extra credit for that, because I mean, especially when you go to PhD, usually people just show you the gateways or roadways, and most likely you need to learn by yourself, which I did in my PhD studies. But in master, it's something between PhD and undergrad. Again, you need to learn how to learn by yourself. I explain more like during the semester and when I today explain syllabus, but it's the way that you need to adjust yourself. At the beginning, maybe looks difficult, and even I was not a fan of that, because when I went from undergrad to master program, I just like everybody just give me everything and just I learn a book and that's it. But I learned that I mean, if I want to be competitive, either in the market or in the schools, I need to learn by myself, because like people don't have that much of time to just teach me everything, because there is the speed of knowledge creation is so much fast that it's not actually feasible. And people might have different preferences. Like, for example, in this class, I teach you general things, but maybe you are more interested on a very specific thing. So, which is like out of content. So you can just get some expertise and knowledge by learning by yourself and just go in depth of that specific domain that you are interested in. Okay, I've talked about your session preference. Let me share my model. Oh, not this one. Let me see. Can you see my model? If you can't, just let me know. So let's see. Okay, I have some comments. Okay, you can see. Okay, in the announcement part, there's two sections. Let me just first go to the Zoom. So basically in the Zoom info, I put the like link to the Zoom session, and you can just copy and paste the link on your browser and just get to the every class that you want to attend the online session, I mean the synchronous format. I try to email you every time that I make a Zoom link, but if you couldn't get the email for any reason, or I forgot, you can find it in the announcement. And also we will have a group meet, same as previous semesters. And I try to post the Zoom meeting links in the group meet too. So there's 3 different ways that you can find the online sessions information. Also, the second link is about your attendance preference. I want to, first of all, I mean, again, because some of you just joined, today I was not sure how many of you are interested in the in-person or online sessions, either synchronous or asynchronous. My preference is just in-person sessions, but I need to follow some certain healthcare measures. So I need to know how many of you want to be in-person classes. If just few of you are interested, I would let you to come to my classes every day. But if like too many of you want to be in person, I have to divide it you guys by chance. So I randomly put half of you Monday sessions, half of you Wednesday sessions. If you click on the link, so if you want to be online session, you don't have to answer the first question. Let's say you want to attend both of them, but later in the semester, I mean, you change your idea, or maybe you have some healthcare concern. Maybe your doctor would say, now again, COVID-19 in the bad situation, and you will have some healthcare concern, maybe you can change to online session, either synchronous or asynchronous. And in the last box, provide your name and Clark email, not like Gmail or Sina or whatever platform that you use. If you answer the first question by mistake, you can even answer it here. Maybe you said, no, you want to be online, not in person. So in this text box, you can explain even if you answer the first question in the wrong way. Again, I just want to know the proportion of you guys that are interested in the in-person sessions. So I can decide either let all of you attend or just maybe let you to attend in just one of the days. I mean, I need to be fair for everyone. So if there's too many of you, I had to divide you by randomly. Again, if you answer these questions wrong, in the wrong way, you can email me, or just even in the comment box, you can explain further concern or information that you want to provide. Okay, any questions so far? Okay, question. Okay, follow your friends, that is clear. Okay, that's good. Let me open the syllabus. By the way, your syllabus is not complete. One of the reasons I was not sure how to divide you guys, and maybe I changed the content a little bit because the teaching speed probably is different, but let me just figure it out. But the content is same. I just want to know how to distribute the days, and also hopefully by the end of this week, we decide about the TA. So you have some TA information here too. But again, my office hours is 6 p.m. to 7:30 p.m. today, and on Tuesday, 11 a.m. to 1 p.m. Again, if these hours doesn't work for you, maybe you're somewhere around the world that times this would be the midnight in your country. That's okay. You can email me, or hopefully the TA, and just arrange a time, and we can just resolve your issue. So no worries if this office hours doesn't work. And class meets are today, which was completely online, 10:25 to 11:40 in Carson Hall Room 231. Wednesday, same time, same location. Okay, let's see what happens about the in-person people that want to attend, and also the TA information. Hopefully, By end of this week, your syllabus would be complete, everything like TA, hours, distribution, and so on and so forth. Okay, so let's talk about the course. So far, I assume vast majority of you, which I almost remember most of the names, had a Python programming class, probably SQL Server, and no worries if you forgot everything or most of them. I mean, the focus of this class is not on programming or data management, but you need to have those knowledge. But the difference is right now, we want to work with the big data. Not just concept, we want to do actual work. So for actual work, you need to remember some of your programming knowledge or SQL Server knowledge. You can review those concepts by the if you can review them by mid-semester, you are in a really good shape. If you haven't had that experiences, or you just worry you don't remember anything, just, let me know. Even a group me, maybe I can share some materials for you. You don't need to be hardcore programmer, but you need certainly remember something, Python, SQL, and so on and so forth. So as you might know, in my classes, most of my teachings on hands-on experiences. Basically, I want you guys to do something, not just memorizing contents. I mean, you have some courses that you can learn contents, and those are great things, but my class is mostly like your actual work. So in this class, just a small portion of it is about fundamental concepts, because I assume most of you never worked with the Hadoop, Spark, or those big data infrastructure. Then I try to have lab almost every day. Basically, we do a small portion of hands-on experiences and big data concepts like MapReduce, which is a methodology. We will learn what does MapReduce means, but basically most of the big data that you learn is MapReduce. It's just application of MapReduce concept. And we learn some platforms related to Hadoop ecosystems such as Yarn, Hive, Apache, Spark. Basically, the first portion, which is Hadoop, you work with like Hadoop ecosystem, you learn how to do like Yarn, Hive, queries. These are for data management, something like SQL Server. Not exactly, but in similar domain. And the last one is the Spark, which is mostly programming. Basically, you do machine learning project on Spark platform on the big data. Having said that, in the Spark, basically it's developed by Java or Scala, but your program is under PySpark, which is Python under Spark, and Spark R. So if you are good in either of those, you can basically do similar thing. You need to adjust your coding a little bit, but it's the reason I'm saying that you need to review something about Python, R, or SQL Server. So let me give you some general idea of how does this course works. Let's say you have big spreadsheet or big SQL data. You need to have a good laptop or PC to do coding. Basically, let's say you want to run a machine learning project on a big data of healthcare. So you need to have a good laptop. Let's say your data is much larger. Maybe you can buy a very good laptop, or at the large cases, you can have a cluster, like in the Clark University, we have a cluster for big data computation. But what if you work in the Apple, like my brother got a job, or like Google, Facebook? Those companies have a very large amount of data. There's two options. First option, just make a larger computer centers, even a supercomputer. I know China, Japan, and United States are really good in making supercomputers. But there's two issues. First of all, supercomputers are very expensive. Maybe it's not a big thing for a like Google, Facebook, or Amazon, those companies. But the second thing, these are not actually a good option for business. I'm telling you what. Why? Um, let's say you're working, you want to order something from Amazon, and Amazon, let's say their supercomputer is in the Silicon Valley, California. Suddenly, an earthquake or some earthquakes, because they come in the cities, it's not just one earthquake, but let's say it happens, or they have some power issues. Suddenly, or somebody attacked them. It doesn't need to be like a terrorist attack. It might be just a bad virus. So at the end, let's say the supercomputer center get totally broken. So they cannot do their business. The Amazon would be done. I mean, they will lose the market. So having one supercomputer not only is too expensive, but also is not logical. It's not safe for any reason. If they lose that center, they lose their business and they get bankrupt. So what big companies do, uh, they make multi-centers. I think one of your friends has a question. Okay, some of you had questions about preference. If you make a mistake in the survey, please email me. Okay, so yeah, and one of your friends mentioned about cloud, but cloud is just the way that you access to your computing power. So even you might have one supercomputer in Silicon Valley, but your main office is in Boston. You use a cloud to reach that supercomputer. Basically, cloud you can consider as a basic infrastructure, and it's actually a part of big data infrastructure. But so we understand that it's not a feasible and safe option and economical option to have a very large supercomputer. So what those companies do, let's say Facebook, maybe at first they have 1 million users, then they make 2 million, then 1 billion. So they just try to add more centers. So they start from one center, then maybe they have so many users, let's say make something, a center in Dallas or Boston or New York, or I'm not sure Facebook is available in China, but let's say in Japan, India. So the Chinese student here, is Facebook available in your country? You can answer me by comment. I'm not sure. In some countries, I know that Facebook is not achievable, but I'm pretty sure in India that people can access to that. So they can make a center in India too. It might help for some communication speed, but the main reason, I mean, they need more computing power and they want to be in the safe side. So they open multiple centers. On top of that, they make multiple copies of their data. Let's say they make a copy in Dallas, one copy in New Delhi, one copy in like Japan, whatever, in Boston. So even if they lose half of their centers for any reason, they still have other centers, and also they have copies of their data. So what happens in the big data when you have worked with a large amount of data, which is still increasing? You need to work with multiple centers, do parallel processing for expediting your process speed. Also, you need to make multiple copies of your data to be safe. You don't want to lose your business by just losing one or two centers. So what happens in the big data? You need to learn a technology that can work with the multi-centers, multi-computing centers, for parallel processing and managing multiple copies of your data. So how Hadoop and Spark ecosystem works. Basically, in this technology, you learn how to work with those centers, how bring your data in the Spark environment and do machine learning. So you already learned the last part, which is using, let's say, neural network, SVM, other algorithm on your data, but your data was not that much large. Now your data is enormous. So you need to learn a new technology to work with those multi-centers, which is the reason Hadoop is created. And it's actually the main goal of this course. So in this course, you learn new platforms, Hadoop, Yarn, Hive, Apache, Spark, and again, at the end, after you can manage multi-center data, you bring your data in the Spark environment and use PySpark, which is Python Spark or Spark R, to do machine learning projects. Okay, any questions so far? Okay, I have a question. Also, Einstein, is Facebook available in China or not? You're not sure? Okay, so anyway, I mean, it's not the main concern for this class, but so working with the large data sets needs two knowledge. The first knowledge, how to design those hardware, how to connect those hardware physically. So that's a part of software engineers. With Hadoop, you can work with those centers and you work with in the last part, which is business, which was working as a business analysis role. So again, hopefully by the end of the semester, you can do actual projects. In this course, we focus in the last part, and also we work in the virtual environment because it's not feasible, and it's not actually the goal of this class, because your goal is not to working with the designing the infrastructure or working the hardware part. Even at the when you get let's say you are lucky, and or in the future, step by step, you get a job in the companies that work with the large data set like Google, Facebook, Apple. The coding is same. I mean, you still work with the Hadoop ecosystem, but the background, instead of a virtual environment, is the actual environment. But basically everything else is same. So in this class, I use a virtual environment, which is same for both Mac and Windows. But I give, but it's a bit slower, because first we install a virtual environment in either operating systems and then use pre-installed Hadoop under that virtual environment. But I give you 2 weeks as extra credit. So you can install Hadoop and Spark directly on your PC. You don't need to use virtual environment. And you can Google it. It's out of content for this class, and it might take a big chunk of your class, because you need to do some extra steps, especially for Windows. You need to do some extra things. And anytime we have issues, it's different for everyone. So I have to use just one option for teaching. So in virtual environment is same for Mac and Windows and even Linux. Within that, everybody have same issues, same concerns, same installation. So, but again, if you want to do the things faster, you can learn how to install Hadoop and Spark directly on your PC. It helps you, it brings you good learning, because you expose yourself to new challenges, and I appreciate that. And also, you do your project and assignment faster. But no worries if you can't. It's a little difficult. It's not too difficult. But you have 2 weeks for installation, and also I encourage you to do it now because it's early semester. You don't have that much of homework. Your free time is much more. And I mean, first 2 weeks, if you can do it, you will be good to go for the rest of the semester. But no worries. You might try it and it might bring some challenges, but at the end, all about my teaching is in the virtual environment, which is same for everyone. Okay, let's talk about the course goals. I mean, first, a small portion of the class is about the concepts because I assume it's first time for most of you that know about big data infrastructure and programming. So I have to do some background. I need to give you some background knowledge. Then we learn some state-of-the-art big data infrastructure and technologies, like I just told about Apache, Spark, and Hadoop. Then you learn how to handle the data. This part is something like SQL Server. So in the goal 4, you learn how to do basically data management. The data now is different. Some data is similar to structural data that you had. What I mean structural data means they have rows and columns. But these days, our data is totally different. It might be a format, column-wise format, which is, I'm sure this could be new for many of you. Or data could be in the text, video, or images. They are not in row and columns. They are totally different format. And at the end, last part, we want to help decision makers. So basically, we want to run machine learning or the data mining projects over the data, and then do some prediction, find the important factors, or basically doing a machine learning project over your data. The prerequisite, I put the general knowledge of programming SQL Server, but again, no worries if you forget almost everything or it's your first time. Our focus is not SQL Server or programming. Our focus is big data management and do some programming. So I advise you just review a little bit. Maybe you can find some online content and just learn by yourself. If you have some issues about the materials, learning material, just shoot me an email and find you some good materials for reviewing. But if you can review those content by the mid-semester, you are good to go. There is no textbook. There is some good books, and maybe I can introduce later, but I provide everything on your model. And maybe I can provide extra materials for you, but you don't need to purchase any textbook. Main topics. We work with the, first of all, we need to learn what is Hadoop and how Hadoop works with the multi-cluster or multi-computing center computations. You do some queries, and there is some queries very similar to SQL, and also you learn what does NoSQL database means and how to work it with the HBase. Then after data management, so far was data management, you manage the big data. In the next part, I introduce the Spark, and we do data process and machine learning project in the Spark. So you can either do Spark PySpark, which is mean Python under Spark, or Spark R, which is R under Spark. And we make some application and bring some insights. So basically, it's like kind of similar to the first semester that we had programming, but now we added one component, which is how to manage big data. Any questions so far? Let's see if you have questions. Let's see. Okay, some of your friends asked question about Hadoop and Spark. Basically, in this course, you learn both. There is a good market right now for them, especially if you want to get to industry jobs, because it's new. It's not that much of people can know that. I mean, usually the new thing is for new generations of graduates. So there's a good market for Hadoop and Spark right now, because it's developing, and there's a good need for that. So I just recommend to do extra work in this course. It's a course that really could help you for getting a really good job. So again, you're a graduate student. Some of your learning comes from your own effort, especially this course, which is very new, and there's too many things. I mean, there's so many technologies under Hadoop ecosystem that we don't have that much of time. So the evaluation is 5% was class participation, but no worries, is you take asynchronous. I provide some questions, I give you 1 week to answer, or so you can even participate in the group me sessions or group me chat, sorry. Take that and you can do some extra thing. And if you participate more, you can even get some extra credit out of your participation. We have some lab assignments. I try to have labs in every session, unless there's a big need for concepts. Like maybe early in the semester, we have more concept teaching, but try to be more in the practical and hands-on experience when we go further. You have a term project, is similar to analytics programming, but the first portion again comes from what you do with the big data. And the total is 100%. So lecture, assignment, participation, extra credit. Again, the first extra credit that I gave you, try to learn how to install Hadoop and Spark directly on your system, either Windows or Mac or Linux. You have 2 weeks for that, and it's not too difficult, but there's so many steps that you need to follow. Again, if you couldn't, that's fine. I mean, it doesn't account for any of your 100% grades, but it brings you good learning. And again, you can run much faster if you install directly on your system. But for whom can't or not interested, I mean, from next class, I teach you how to make a virtual environment on your system and do everything. So virtual environment is same for everyone. So even if there is some issues, it's same for everyone. So my teaching focuses in the working with pre-installed Hadoop on virtual environments. The grading policy is same, and again, let me just update the syllabus by end of this week. Hopefully, I get your distribution, see how many of you be in person. I changed the content a little bit. Also post the TA information here. Hopefully, if we end up having a TA. So again, by the end of this week, you almost get a complete syllabus, hopefully. So let's see if you guys have any question about syllabus, grading, attendance. Okay, if there is no question, let me just open the slides. My goal for today is not teaching. Actually, I just want to have a small introduction and give you just a feeling about the course. Yes, I mean, hopefully by tomorrow you get the group link and every information. So again, one of your friends asked about the group chat. I'm going to create it tomorrow. The reason, I mean, today I just thought, like, I'm not sure why, but I just see information of half of the on model. Not all of it. Right now there are 30 students in the class, but morning when I look at the model, or yesterday, it was like 10, 20. So I assume that it was some issues. I'm not sure why, but yeah, I mean, I create the group session hopefully by tomorrow, at most by end of this week, and you can access to the material through that. It's one way of accessing. but announcement, and I also use announcement and emails. Okay, let's talk a little bit about the course. So we are in the 4 V's dilemma of big data. Means the velocity of data generation is too fast. I mean, also like every second millions or billions or trillions of data is created. It could be even Facebook comment, YouTube video. Even now I'm creating online content because I'm going to share this video for the portion of you that take it in the asynchronous format. So for that, we need to increase the processing power system. We need to and increase the system capabilities. And how to work with the online data. So in the first semester, you work with the like a chunk of data which already downloaded and ready. But right now we have a stream of data. So like Facebook comments just generate every second. So it's not the way that you pile the data then process. Maybe you need to process a stream of data. It's totally different. And totally different from the like traditional data processing. Also, the data variety is just changing so fast, and we see new types of data like social media, videos, IoTs that comes from RFID tags, so on and so forth. Even text data, or we are in the NoSQL era, so some data is not under SQL structure, which I explain later. So we have new kinds of variety of data, and also volume is too much. I mean, like 2.7 billion comments is generated by Facebook, and Google processing 24 petabytes of data is just every day. So it's not even imaginable. Every minute, as Foursquare handles more than 2,000 check-ins, TransUnion, and so many other things. So again, for this amount of large amount of data in the speed and different formats, we need to have new technology or new infrastructure, which is the reason we are learning Hadoop. And also we have veracity issue, which means there's some uncertainty about data and data quality, which you might talk about the bias in machine learning is because uncertainty on the data. So these are the 4 V's of the big data. Again, my focus in this class is not to memorize everything. I mostly take care of how you handle data and solve the real issues, but it's good to learn some basic concepts. This is a real new thing. Maybe later you need to know. So just spend time. Maybe you can Google, and just if you have some question about like different veracity things or volume, you can do your own search too. And at the end, we want to get some value out of data, the big data, and make some decisions that brings value for the business. Okay, let's. I don't want to teach you overwhelmingly a big amount of data, but let me go to one of the slides that next class I teach it. Okay, lab 1. So in lab 1, I teach you how to install a virtual environment. As I said, in this class, I teach in the virtual environment because they have less issues for installation. It's much easier, and also it's same for everyone. So it doesn't matter you use Windows, like Linux, Mac. So first of all, you need to install a VirtualBox, which is prepares the virtual environment. Then you need to download and install HTTP platform, Hortonworks data platform. This one is a really large data. I think it's 15 gigabytes. Is that much big? So you can just install ahead of time, but again, I teach the lab next class, so no worries if you don't have time by Wednesday. So on Wednesday, I teach you how to have a virtual environment, which is much easier. And again, this is within the content of this class because you need to learn how to work with Hadoop and Spark. And even when you get a job and you work with the actual infrastructure, it's a portion of the job that you need to handle. You're a business analyst. Again, this is the way, and it's just I'm pretty sure all of you can do. But again, if you want, you can install on your system. You can install Hadoop and Spark directly on your system. It's much faster and it brings good learning for you. I'm not sure if you're a fan of 3 hours or 1:15, but I think if you are a full-time student, maybe 1 and 15 minutes is a better option. I think if somebody might have a full-time job, they rather have a 2 half-a-days or just one day for the teaching, for the education. But a full-time student, I think it's better to distribute the hours within a week. So it might be much more productive. Again, that was for today. Again, today's purpose was not for teaching, for bringing some general introduction. You can spend time, read the slides, install the virtual environment if you have time, or just install directly on your system. You have 2 weeks for that extra credit. I provide the information on your Moodle. So no worries if you forget them, but basically you need to know how to install it directly, and maybe at the end I ask you to take a picture from your installation so I can see you could do that and get the extra credit. Is there any questions? Okay, I have one question. Oh, actually, there's no question, just everything is clear. Again, from now, anytime you have a question, you want to speak, you can use your microphone or your camera, and you can have interactions. Even when we go to hybrids from next day, from Wednesday, still you can participate in the class discussion. One of your friends asked me, should we install Java 8 before installing Hadoop? Yes. If when you Google it how to install Hadoop directly, you see that not just Hadoop, you need to install Java JDK, even not Java 8, JDK, Java Development Kit. And also on top of that, if you use Windows, you need to copy and paste some extra files. They call it min-utils. In Linux and Mac, you don't need. You have one step less, but Windows is not too difficult. It's just several steps. It's the reason I gave you 2 weeks, because I know if it's your first time, it takes a lot of time. But again, no worries if you couldn't figure out how to do, because your content would be in the virtual box or any virtual environment. So I'm pretty sure everyone can do that. And also I teach you how to work with the virtual environment from. Any questions? Okay, let's finish today. And from Wednesday, we go to actual class and actual teaching. And also, we have our first lab, which I teach you how to install the Hadoop over the virtual, using a virtual environment. Okay, thank you very much for today. It was my pleasure to see you after a while.